Supplemental math videos from Circle Christian School. The sum and product of a quadratic equation. Well, why oh why should one know these? Well, because there's this cool relationship between the coefficients and the roots of a quadratic equation. And not to diss the smart mathematician who figures this all out, it's all about the process. And the process is what allows us to do and be better subjects in the kingdom of I, and hopefully playing with something leads us to a little bit of insight that helps us on an SAT or an ACT, that logical reasoning thing. What is the nature of a root? Well, the nature of the root is what happens with the discriminant. The negative b squared minus the 4ac tells us whether we're going to have a real answer or if we're going to have two real answers, an irrational number that has a radical in it, or whether it's going to be imaginary. Well, the reason why we factor to begin with a quadratic equation is just so we can find the roots to begin with and setting them to 0. So our first root is derived from x plus d, so it's going to be a negative d, and then x plus e, which is going to be a negative e. Well, great mathematicians figured out that there were things that happened with the coefficients, that the sum equaled negative b over a, or plainly put, the root 1 plus root 2. And the product equaled c over a, those coefficients, or the first root, times the second root. So we can take the equation where here a equals 1, and b equals 3, and the c equals the 2. And if we factor it, we get our first root is negative 2, and our second root is negative 1. So we can add them together. Negative 2 plus the negative 1 gives us a negative 3. Putting it back into the coefficient form gives us a negative, and then the 3 over the 1, which gives us a negative 3. Same answer. Likewise, if we do the product, we would have the c, which is a positive 2, over the a, which is a 1, which gives us a 2. If we multiply those two together, we'd have 2 times the 1, which of course is a 2. That's the nature of the root. We can also find what is left over in an equation as long as we know some certain facts about it, either the b or the c, and at least one of the roots. So remembering that one of the roots here is 2, and if we add it to the second root, would give us the coefficients that we do have provided to us. B, which is a 3, and B, which is a negative 2, and the A, which is 3, now gives us 2 plus the r squared. And so by subtracting the 2 from both sides, and if you think a little bit about fractions here, 1 over 1 would be 3 over 3. So 3 over 3 plus 3 over 3 would give us 6 over 3. So instead of looking at the 2 here, we can look at 6 over 3. And that gives us a negative 4 over 3. And that would equal our second root. Now taking our first root and our second root, since we have both of them now, we can take 2 and times that to the negative 4 over the 3, which gives us negative 8 over 3, which is the c over a. We now have the c, which equals a negative 8. All right, and we can try it and test it out. I'm going to just put the negative 8 up here and just do my little factor by grouping thing. And let's see, we have 3x factors for a negative 24 that when we add them together equal a negative 8. 3, 8, 2, 12. Hold on a sec. Okay, I knew that didn't look right. Not a negative 8, it's a negative 2. That would make better sense. That we would have 6 and 4. And the 6 would be the negative and the 4 would be the positive. Okay, so I'm just going to rewrite this a little bit over here. So we'd have 3x minus 6x plus the 4x minus the 8. We're going to do our little factor by grouping. And that gives us the 3x, x minus the 2, plus take a 4 out, and it's the x minus 2. And so we end up with 3x plus 4 and the x minus 2. So root 1 would equal a negative 4 over 3, and root 2 would equal a positive 2. And if you kind of go back to some things that we did before, you would see that would work with the roots that we had. Quadratic roots, using the quadratic formula, are negative b over 2a plus square root b squared minus 4ac all over 2a. So that would be our root 1. And of course the minus, because we had the plus minus, so that would be our root 2. These are actually conjugates, or what we have, the difference of two squares. So I'm going to take root 1 and root 2 with values inside them, and the whole thing is to find the equation that we began with, to be given that, hey, here's some roots, what was the equation that we started with? So I'm going to do the difference of two squares, and the first guy is always squared, so that's going to be 4 over 9. And then we're going to square the last guy, which is going to be 16, 4 squared, and square root 5 times square root 5 is 5, and that's going to be over 3. So we get 4 over 9, over 9, square root of 3. You should always end up with a common denominator to begin with. So minus 5 times 16, 3 is 80 over the 9, which gives us a negative 76 over the 9. So since what we did was take our root 1 and multiply it to our root 2, the negative 76 over 9 would give us the c over a. So now we have part of our equation. We have that a is 9x squared, and our c is a negative 76. So now all we have to do is go find our b. Okay, so I'm going to do a little bit of erasing here just so I can move on and have some room. And what we have at this point now is that since c over a equaled the negative 76 over cuckoo clock. Okay, the negative 76 over 9, which gave us the equation of 9x squared plus the bx plus the negative 76. That now we can go find our negative b over a, which we know is over 9, and we're just going to take root 1 and add it to root 2. So we have 2/3 plus 4 square root 5 over the 3 plus 2 over 3 plus the, minus the 4 over 5, 3, which means this guy right here is going to cancel out, which is going to leave us with 2 over 3 plus 2 over 3, or 4 over 3. And now we can just cross multiply to go find out what the b is, and we get 36 equals negative 3b. So b equals a negative 12. So our final equation is 9x squared minus 12x minus the 76 equals 0. And we got all that because we knew what a couple of roots were.